Hello everybody, and I'd like to welcome y'all to the Past Data Architect virtual chapter. Today's presentation is Lewis Davidson talking about, as always, relational databases. Session is titled, How to Recognize Your Relational Database is, quote, Good Enough. Lewis comes about once a year and does a great presentation for us. Just to give y'all some more information about PASS, there's plenty of resources available if you are interested in being part of the Professional Association of SQL Server. It's one of the largest user-based volunteer communities for technology. There's 24 hours of PASS. SQL Saturday is probably near you. SQL Rally, which is in some of the countries outside of the U.S. There's local as well as virtual chapters, all kind of free online technical training through virtual chapters as well as others, and the PASS Summit, which we'll talk about now. It's October 14th through the 19th. Lewis Davidson will be doing a pre-conference session. Lewis, is that Monday or Tuesday?
Tuesday.
Tuesday. So you can actually go and sit with Lewis all day long and learn about relational databases. On Monday and Tuesday are the pre-conferences, the regular sessions, which are 75, 90 minutes, half day, as well as lightning talks and continuous clinics, all kinds of stuff. If you have never been to a summit, I strongly suggest you go there. I actually like going to this conference more than the Tech Ed. I get a whole lot more out of it, and you get to mingle and network with lots of people who are interested in SQL Server. So this is our presentation today. If you want to get involved with this chapter, email us at davc@sqlpass.org. We have a new email address. We usually have a speaker on the third Thursday of every month, either noon Central or Eastern or even maybe another time zone. If you're interested in speaking, please give us an email, and you can follow us on Twitter as well. It's DARCVC. And if you want to help with the chapter, go ahead and give us an email. And I am going to turn this session over to Lewis.
To be clear, I also like to talk about Disney World and and football. If anybody wants to stick around afterwards, talk about that.
You're talking about Tennessee football?
Any kind of football, but obviously that.
Thanks,
Boy,
Lewis.
Tiger fan. So since he took 3 minutes of mine, we're going to run way over today. It's not nearly enough time to get done. I'm going to try to keep the jokes down to a pitiful minimum like that. So today we're going to talk about how to recognize when your relational database is at that pinnacle point of good enough. So who am I to tell you what's good enough? I've been doing this for a really long time. I've been a corporate data architect. I've written 5 books on database design. Now, does that mean I'm some super expert genius? It means I've written down kind of the academic definition of what good enough is a few times. But there's clearly some difference between what you're actually going to be able to do and what is really good enough, because there's a lot of realities on your time. So today we're going to talk kind of just some points and details you want to look at and to know whether you've done a good enough job or not. So this is a saying that just really burns me because generally speaking, how do you know what's good enough? And who gets to decide what good enough is? You get a manager and they're like, okay, that's good enough, let's go on. You're like, it's not even close to good enough. It'll do, it's good enough. And it's generally a problem unless the person who's telling you it's good enough, if they don't know what good enough is, it's probably not good enough. So in the next hour, we're going to seek to talk about what makes a relational database good enough. And hopefully you will never have to hear that term and not be able to snap back at the goofy manager who says, I know what's good enough, and that's not it. And if you get fired, please, my email address is the smilingdba at something or other, I think. So the first thing is, if you want to know what a really bad database system is, see if people are writing down before they enter into the database the information because they're afraid they might lose it. So that's I've seen this. You have places where they're writing it down and then they enter the data, like a phone call operator, because they're afraid that somewhere in the process they're going to lose the data. So the number one characteristic of a great database is that it just works. And if it doesn't just work, then you're just completely out of the, you're way out of the band. You shouldn't even be talking about, do I have it looking good? Do I have it operating the way it should? The fact is, if it doesn't work, it doesn't mean anything. And so in this particular point, we and developers really kind of get along. As we move along, though, it's not going to be just that it works, but that it works well, and it works in a way that's natural for the people using it. And it works well is what you're looking for, not just you got something that works. That piece of paper will actually work. People were doing business on paper for 6 million years. Okay, so the number 2 one is the user says, I want an apple. You give them an orange. It's a piece of fruit, right? It's really close. And they say, this is okay, but not what I want. Could you bring me an apple? And in this kind of Scrum, Agile sort of time, we have this sort of thing where we're doing things really fast and we're trying to get it done. And it's an iterative process, and that's okay. I mean, if you bring an apple and maybe you want a pear is much closer to an apple, right? So you're trying to get as close as you can to what they want. So before you get started designing, someone needs to really understand the user's requirements, because it's impossible to end up with perfection. But if you don't even know what perfection is, you're never going to get there. And again, one way or another, it doesn't matter how. It doesn't matter if it's really pretty database, as long as you know what they did, what they want to do. But the best kind of advice I'm going to give you is to find out what great is and try to emulate it. If you try to emulate mediocrity all the time, we're just going to do this basic job. We're not going to get a good job done. You're going to fail at that, but you're going to fail at being mediocre versus failing at being great. All right, so those are my really non-technical points. This point is a little more technical, and this is the Doppler effect. And when we think of the Doppler effect, we think of a performance car coming by us, right? So the next one, and that's the last sound effect I'm going to make as well too, is that it's got to work well. So we've got it working good. We know it does what it's supposed to do. It doesn't matter if it takes 2 weeks to enter a value, as long as that value is right. People are not going to kill you. So not thinking about it in computer terms, we've got this really high-performance sports car, and we've got a Ford Taurus wagon. Which one of these is faster? Well, I mean, you're immediately going, the race car's faster. I mean, this car's probably $300,000. That Taurus wagon's probably $1,000 on a used lot right now. But you have to think about it more in terms of what's the purpose I'm doing. If I'm going to race these cars, which one's going to win? Well, you got to think about what kind of race. Is it a family of 4 with luggage to the beach race? So we can optimize our queries to the point where, obviously, the Taurus is going to win. We can optimize our queries to death for the single user community, the single user kind of situation. But when we push this out to a big server and we think, what about 10 million users? Your boss, you've got a website, and your boss says, okay, everybody who comes to my website, in the next 10 minutes, we're going to give you $1,000. Your website's going to crash. It's going to blow up, and if you're not prepared for that sort of thing. So it's got to work more on, not just on your machine, but everywhere. So my kind of philosophy here is, when you're doing your first design, forget about performance. There's no need to worry about it. Performance will fall out later in the process. You design for the requirements and get it right based on relational theory. Then you implement that design and still don't think too much about performance. If it's slow on your machine, then you should consider that. But don't ramp up with lots and lots of data and think that that one situation is going to do. At PASS, I've got this presentation on hierarchies, and I loaded a 600,000 node hierarchy, and I ran it. I didn't consider, to see how just on one machine it would work. I didn't load it up like a full situation where I have thousands of users running it, and that's something you need to do as you move along through your process of getting things done. Third, test. Start making sure doing your unit testing, and then if it's slow, continue to do performance testing. Don't hit the blank button. And then finally, load test, and test as close to what the real situation is going to be like. And that way you get to the point that you've got it right and it works fast. And a lot of times you'll find that what didn't look fast because your mind is thinking like a procedural programmer will really work fast because the declarative engine of SQL Server will take that query and will turn it into something beautiful and make it work even though it looks like it's going to be a lot harder. It's a lot of this kind of pre-tuning that people do that really gets out of hand. So we're going to look at things and we're doing performance like indexing. There's certainly something known as to having too many indexes. The more indexes you have, the harder it is to maintain blocking and stuff like that. But I guarantee you having too little indexes is way worse because you'll end up scanning a table. And if you scan a table and you're doing an update, all the users are probably going to end up waiting on your process. You're going to end up with deadlocks and things like that. So run lots of performance test scenarios. Always test multi-user scenarios. Make sure if you're doing something that requires a concurrent, two people doing concurrent operations on the same kind of data, same row, that you've tested not only, is the locking good, can the disks handle it, do I have enough memory? When you're doing your query plans and check to make sure that you have good logical reads, but then make sure you're not getting a lot of physical reads. Physical reads don't tell you much about the query performance. They tell you a lot about your server performance. Look at the code, limit temp tables. A lot of times people will make a bunch of temp tables to optimize a query. It's a good technique, but it can also hamper the performance of the engine. Cursors are horrible. Going back to the hierarchy situation, to load 50,000 rows into a table, I can do it in about 2 seconds in a straight one row, one insert, all the data at one time. But to do it one row at a time, one of the things takes about 4 hours to run. So I was doing it to demonstrate, how it works when you have concurrent, when you have singleton inserts like in a normal situation. But anything you can batch up into a single operation is going to be faster, because not only does constraints have to fire once, but only one kind of log write. There's only one kind of thing. But look at cursors, understand cursors, make sure you're using the right kind of cursor if you have to use a cursor. Use local, not global. Over-modularization. SQL Server is not great at modularizing code to death. And people get into this idea, that as a programmer, if I have to see the same bit of code multiple times, I'm doing a bad job as a procedural programmer. But SQL Server basically takes your query and then turns it into a picture. It sees what it can do with that. If you've forced a bunch of views that have their own thing, their own plans inside of there, their own kind of way to operate, SQL Server's engine gets a little confused when you have hundreds of these things, even though it looks like you have 1 or 2 tables involved. So be careful with views and layering. Sometimes it's best to have just to repeat a little bit of code here and there to get the kind of queries you need. If you don't know about query plans, if you don't understand that, how SQL Server's engine works, it's really a good idea to find out before you start writing really complex code, because you're writing in a declarative format. You're saying, you're asking SQL, select star from table, and you're just asking it this little innocent looking question, but it's turning it into millions of rows of operation. It's doing a lot of millions of rows of code and doing all sorts of stuff to optimize that and make sure it comes back fastest. So understanding what's going on under the covers in a declarative language can help you to format your engine, format your source and your queries and everything the best way they can be done. Make sure you're doing the proper seeks and scans. Some queries are better if you scan. Look at the dynamic management views. Like I mentioned the other one a minute ago about indexes. Or I didn't mention it, but it was on the slide. There's one that'll tell you what indexes are being used. This system.io virtual file stats will tell you how busy your file is, how long processes were waiting on it. It'll give you an idea if you have a fast enough disk system. If you have enough RAM, you'll never have to go to disk except to write log rows. So make sure you have unique rows, scalar column values. SQL doesn't really do very well parsing values out of columns. It only does it fairly well as long as you are looking at the first characters of the column and you do format your code the right way, like with a like and not with a substring necessarily. They get better every version, at figuring out what you're doing and making bad code better, which is really great. I mean, I'm not saying that's bad, but the more you get it right, the faster things are. And then concurrency, don't use no lock just to make things go faster. You know, it works is the most important fact. And if you happen to lose data because you've used no lock and because you didn't take the time to do indexing and figure out what's really going on, that's really kind of a sucky thing to do to your users and to yourself when you get called in the middle of the night when they're like, why isn't it working? So number 4 is this guy. I think we all should have little rubber noses, us normal people.
Hey, Lewis.
So normalization. Yo.
Lewis, you got a question real quick? How about using temp table variables instead of temp tables?
Sure. There's value to temp tables. There's value to temp table variables. It's based on the size that you use. You should really look into what you're doing to the optimizer. I mean, if you can you can add any indexes to a temp table. You cannot add indexes other than a unique constraint to uniqueness constraints to table variables. Table variables don't cause recompiles, whereas # temp tables do and double # temp tables do. So absolutely, look into all that. Really understand the code that you're writing. That was the point of all this is don't just write code and expect it to work if you're doing really big things. And that's kind of where a lot of programmers get messed up is you can write a system for 10 users and do pretty much anything, and SQL Server will do great on a laptop, right? But if you scale that up to 1,000 users or 10,000 users, or the Christmas traffic where 1 million users come to your website because they just bought the new toy that your company makes, then you're really hosed, right? And so you got to scale up your thoughts. Do it right the first time. You don't have to do that as much. So back to this guy. I was looking for a picture to come up with normalization a few years back, and this guy just said it all. So normalization. This sounds like a horrible, horrible thing, but it's really not. It's really just an instinctive process that we do when we're designing storage to store bits and pieces of data. If you give us your administrative assistant, because we all have administrative assistants, right? I know I have 3 personally. And you ask them, say, okay, make me a spreadsheet of all of our customers and all of our sales. They will not make one spreadsheet with some big hierarchy all built into that one file. They're going to make a couple of spreadsheets. They're going to link the spreadsheets together. They may start out the wrong way, but they're going to figure it out because it's going to be really messy. That's what you're doing, only what we have to do is go deeper than that and look for all the little repeating bits and pieces and make sure it fits in correctly. It's just common sense. And usually, and I'll get this in a minute, it's usually our fault when it's not common sense. So briefly, we want to make sure columns have one value. You don't have a comma delimited list. You're not repeating a bunch of values inside one column. Every row in a table is unique, and not just because it has a uniqueness constraint, a primary key on an identity column. Because if all the other columns can be duplicated, identity columns really have no meaning. That we use an identity column for an artificial surrogate key, and a surrogate key means stand-in, like a surrogate mother. It's the mother standing in for the real mother because it's more convenient or more because of health problems. Whatever. I don't want to get into that thing, but the problem is they're standing in for them for some reason or another. So you got to be really careful with uniqueness constraints. Proper relationships between tables. We want to make sure that we don't have a bunch of repeating data. Every column is either describing what the table is or it's a key from another table telling us, something about that row. And then we're scrutinizing dependencies. You make sure if you have 5 or 6 tables related together that they're not telling you 5 or 6 different things, that they should be telling you one thing, because every table should have one meaning. There shouldn't be some, one row means a dog, one row means a cat, one row means a product. Every row should have the same kind of meaning. This keeps the user without not having to think about what's going on. So how normal? There's this myth. 3rd normal form is enough, and anything, if your database turns out to be in 5th normal form, all of a sudden your system runs slower. Well, typically, if you're in third normal form, you're already in fifth normal form. And if you don't know what fifth normal form is, it just sounds scary, but it's not that big of a deal. It's more about the requirements than anything else. And that's where the process falls down. We have someone who says, I'm going to normalize this database to death. And they don't think about what the user wants. They think about what they want, what the natural world says can be broken down into pieces. As an example, I've got a user, and I want to store their complete names and possible aliases. I got their first name and their last name, and then I've got a box here that they can stuff in a bunch of aliases. Is this a good enough design? Probably not. Probably you want to have Mr., Mrs., Junior, and all that on the first name. So that's probably not good enough to start with. But what about aliases? Can I put a comma delimited list of aliases in there? Absolutely. If you're never, ever, ever going to, from SQL, select out of there, or possibly with full text search. But you're never going to use SQL relational queries to ferret data out of there. You're okay. It's like any document. You can put a document in SQL Server, and we'll get an example of that in a few minutes. It's really what the user needs. It's not what the natural world tells you. So if you're making the user do more work than they want to do, you're not doing your job right. It's mostly just common sense. So we have a book. We want to source some information about books. So what's wrong with this table? Well, lots of books have more than one author. The MVP Deep Dives book has 50-some authors. And we blew up a bunch of publishers' databases when they tried to send it out with 50 authors, so we ended up just being able to send 5 or 6. We use the editors. So that's not good. But if they did try to fix this, some users would do pretty much anything to make their data work. They're going to slap an extra value on the primary key or alternate key or whatever that value is there. Or they're going to put comma delimited lists. And this may be a surrogate key from another table, maybe 1, 2, 3, 4. And if you let them, you build the structures so they can do that, they will do that. And this doesn't make users bad. This makes users crafty. This makes users thinking like you do. How would I solve the problem? But they're not trained in building a database. Obviously, some of you are, hopefully. Or after today, certainly will be. Yeah, there's a lot more practice involved. And all this stuff seems easy when you talk about it, but it's really about practice and taking the time to figure it out. So what would a common programmer fix would be to add a repeating group. And that's great. Okay, we've said 3 authors. Maybe that's our business rule. But even this right here is problematic. Because what if you have some set of columns like this? This does not come from a real scenario in my company, unless you work there and you know it probably does. We have these 3 columns here. So what do we do now? I want to know if email 1 is an active email address. I want to know if we can use email 2 to send them certain kinds of email. So we end up with this. Now I've got 12 columns, and I've still only got 3 email addresses. So now we've got the status and the type and the private if it's private, and it just gets out of hand, and you end up with this 500 column level table. That's why you can have 30,000 columns in SQL Server now with sparse columns, because sparsely needs some of these columns. Not really the idea. You want to make a repeating group. You want to make another table for each one of those things. So when we need to add additional information, we just add additional information. It just works. It seems like more work up front, and it is. But the goal is, because every table means one thing, adding some meaning to that one thing is very, very easy. Okay? It doesn't make writing UIs any easier, but who cares? That's somebody else's job. What about this? I've got a driver, and I want to know I want to know some information about the driver and get some details so I can help pick whatever car we want to run into them. So we look at the dependencies. The driver is the key, and those are 1 person per row. That's good. So we look, and does everybody own a vehicle? Yes. Can you own multiple vehicles? Possibly. So there's one question. When we get to naming, you'll think that should either say primary vehicle owned, or you should probably allow them to have multiples. Height and weight, eye color, weight, whatever, those are all perfect. Everybody has 1 height. At any period in time, you have 1 height. If it changes tomorrow, it's still you have one of them. What about wheel count? But what does wheel count mean? Obviously, wheel count sounds like something that a person doesn't have. I have not got wheels on my feet, ever. And some people may go roller skating. Okay, fine. So drivers don't have wheel counts, but is that the wheel count that they will accept? So Lewis will only drive vehicles with 4 wheels. Rob will drive vehicles with up to 18 wheels. Or is it saying a tractor trailer has 18 wheels? That's what you have to design. This is one of those things where I say you can't judge a database by its structure, because you have to know what the intent is. And without naming things properly, you're really not going to be able to do that. The more you name things properly, you really kind of make those things come out. But in this case, the requirements turned out to be the wheel count is the vehicle. A hatchback has 4 wheels. There's no 6-wheel yet. So this is the kind of thing you do, and make sure you get it right. And think and think and think. And I'll be honest with you, these are very simple examples. It's not exactly rocket science deep examples. Your examples will be much more difficult, and there'll be a lot more people arguing with you than just me, when you come up with your ideas. See, but we don't need 2 tables. That means I have to build more screens. And you're like, okay. Isn't that your job? Isn't that the whole goal here, is to do something perfect and pretty? So once you get to 4th normal form, we've said that the table other than the keys are correct. But we want to look at the keys. And a lot of this stuff just comes out because if we have some more attributes here, you would go, that's not about the class, that's not about the book. It would have to pertain to all 3 of the attributes. But if that all works out well, now we want to look at the attributes and say, what are the dependencies between the key attributes? Class determines trainer. Certain people are qualified to teach the class. Class determines book. Certain books are good to teach in the class. Trainer doesn't determine book. So we're saying that by definition, Lewis can use any book that's set up for normalization. Fred can use any book. So then they're not related to one another. If it turns out they were, then all the columns are related to one another, and we're still okay, still in 4th normal form. So that's the kind of stuff you want to think about. And if you find yourself doing this, select distinct from a table, really question if that's a normalization issue or if it's something that's natural. It's not wrong to do that. Just show me all the classes and the books that have been used. That's okay. Show me all the classes and books that are in use, that can be used. Then you start thinking, wow, that really sounds like a table in and of itself. And then you have to do a sort and whatever to find out, get that information. It's not rocket science at all. So now we break them into different tables. Class is really the thing that we're trying to store information about. All fine and dandy. 5th normal form is pretty much the same thing, but you take those, if it was all 3 rows, 3 columns were related to one another, you'd break the table down and see if the meaning is still okay. If you come on pre-con, we'll talk about that for another 10, 15 minutes. Yeah. So why are we normalizing? Data integrity. Parsing data is messy. Duplicated data gets out of sync. Out of sync data means users are angry at you. I don't like users angry at me. The engine particularly was built to deal with normalized data. Normalized data. It was built that way. Those people on the engine team have the same sort of structures that you have. COD has a set of 13 rules, which are called COD's 12 rules. Find out why. It's kind of humorous, but that kind of define what the future is going to be like, and we pretty much are still trying to attain those values to get it right. Eliminating duplicated data. If you have duplicated data, you have more disk space. You have more disk space, what does that mean? You have more reads, it's more costly. What about unnecessary data tier coding? Everybody talks about how it's hard to scale out the data tier. And it is. It's not as easy as anything that has state is harder to scale out. So the more you can get it tight in the data tier and not have to do a lot of work to validate data is correct, the better. So, but just make sure you consider the requirements. Almost every value, almost every table could be broken down into multiple tables. Document could be a complete document, chapters, paragraphs, sentences, words, characters, bits. What is the actual need? Why are you storing a document? Are you storing a document so a user can edit it, send it back to you as a complete document? If so, store it as a complete document. If you want to be able to have multiple people working on a chapter at a time, store it as a chapter, a section at a time. If you want to be able to count the number of paragraphs, store it as paragraphs. If you want to know how many times the word blue is used in the document, and this is a very common thing for you to count the number of words, store it as words. So the right way is determined by the need. It's all up to what the user needs. It's not up to what you could do. It's not an academic task. It really sounds like fun for it to be an academic task. And it is fun to sit down and do this sort of thing, and I'll suggest that later, that you do that, but it's not that you should do it for the users. Okay, so don't make me think. When I worked for a web company, and one time they made us read this document. It was really good because when you go to a website, you shouldn't have to go, what am I doing at this website? Where is the stuff I want? It's the exact same thing for a user of a database. I like puzzles. In fact, I made this maze to draw itself. I don't know if you can see it draw or not. But you know, I made this to draw itself. I'll go through that quickly. And that's fun, right? But a maze is not what you want to put your users through on a daily basis. It's not a design goal. Because an incoherent design means people are sitting there spending time trying to figure out where stuff is. And what makes it even worse is that mazes have been worked out. There is an answer to a maze. There's not always an answer to a data question. If I know there's something on the web and I can find it using Bing, you know, I'll search for it all day to try to find an answer. But I don't know that the answer exists. I'll start asking people. If I didn't have to do that, if it was right there and it made sense, I wouldn't have had to waste any of that time. The data should empower your users, not make them angry at you. So the idea is that users see your schema, they should have an idea of what's going on. So develop 8 human readable standards and apply them all. No, wait, no, that's not right. Apply one standard and apply it to every kind of thing you build. So most of these mucky databases start out with the best of intentions. You got some old system where somebody's put just a bunch of names and it's been added to. They've got mob area code. We're thinking that's mobile, hopefully. And then we got mobile exchange. So these are really names you should probably have done better. So the next person comes in and they add a table and they use their own standard. They've added the product name. They didn't call the name prod. They called it prod for some reason and not product. Don't know why. Could be they believe table names should be less than 4 characters. I think that's kind of hideous. The next person comes in and they like spaces in their names. And I like spaces in the names too and looking at them. I don't like spaces in the names when I'm working on it because then you got to put those stupid brackets around. And it just goes on and on. You know, order ID here, order number here, but I've got an order number column here. And I didn't take this out of a real database, but it's extrapolated from many things I've seen, particularly on the forums. My MSDN forums, you get to see some fun stuff. And it's not that it's funny, and it's good that people come and get help. So I'm not laughing at them. I'm just saying it's amazing the things that you do when you don't really have the training. You haven't really thought about what it does. So first thing I would probably suggest is avoid a bunch of abbreviations if you can, because abbreviations mean everybody's got to follow the same abbreviation. If everybody didn't have to abbreviate Tennessee TN, you know, if it was TNN or TN or whatever, it makes it confusing. Everybody has to think about what does that mean. Singular or plural, I prefer singular because the IDF1X standard for data modeling taught me that way. I've seen a lot of people say plural, that's fine, but stick with one. Okay, get it the same way. Columns are generally singular. Maybe the name itself doesn't look singular, but the root of the name is singular. I follow a particular pattern I'll share here where you have a class word at the end, and this is extrapolated from a lot of different things I've seen over the years. And it's just to have a name. So if I have a table, company.name, I know that's the name column. That tells me what the name of the company is. If I have a company.username, I know that's not the username of the person who's entering the data, right? That's the username of the company at probably some system that we have, and that's how we know it is. If I have a company.saved username, I'd have company.saved by username, and I would know that's the user that saved the company. And did they save the company from ruin? I don't know. It depends on what your database is. You really got to think about the context of names. In date, I try to say if it's a date, it has no time. If it's a time, it's a point in time, which unfortunately doesn't mesh with the time data type. But pledge amount is an amount that was pledged. So we use amount as kind of the, and this is where I said singular, sometimes it doesn't look singular. If I have a scale, I might add that to there and say this is the pledge amount in euros. I don't say dollars because 99% of the time in America, I see a money column. It's a column storing money. It is in dollars. I don't worry about other kinds of values. Distribution description. So the table name dot distribution description. You kind of put the name together and you know what it is. Ticker code. So come up with some class ending word, name, date, time, amount, description, code, and make this kind of standard naming thing and force yourself into it, because sometimes it's not convenient. It doesn't feel right, but it sure looks right when you're trying to figure out what a name is later. So the goal here is if you have a good system, your company does a good job, all your databases will look like they were done by people who have some idea of what they're doing. If it's great, it'll look like every database was built by one person who knew what they were doing. And if it's perfect, then you got all your databases, and I'm waving my hands in the arm for this one. You got all your databases, and they look like they were made by one, came out of one mind. It's not possible, of course, but it would feel really good. I see I have a question. I guess it's lunchtime, so you're going to have to stop eating your turkey leg. Sorry, yes, come on, faster. We're a vendor and don't want to share out their schema. So they obfuscate it. Oh my gosh. This is my least favorite practice of all practices, because it comes down to this. You can hide your schema from the average user, but you can't hide your schema from me. If I want to know what's in your schema, I can get that schema, look at it, take the data that's in there, and figure out what 99% of it is. You know, and hiding what the name of the data that you're storing in a database for your customer is just a hideous process. If you have things you want to hide from them, like algorithms, put them in a CLR object, put them in the code, put them somewhere where you can't get to it, but don't make it incoherent for the user, because they're the ones giving you money to use your system. I see that a lot. It really just burns me up. I've spent many hours trying to figure out databases. So the next one is obviously make sure your data is clean. Because if you're an ETL developer, I'm sure there's a few of you, you feel like this. This is how I feel after the end of a day of coding an ETL. Because from a system that doesn't have a bunch of keys or really integrity. Because this is wrong, and then you'll start loading it, and this will be wrong, and then this will be wrong, and this will be wrong. And it just makes you want to hurt somebody. Make them look like this. So we want to make sure that when someone puts data in the database, it remains correct, no matter what the user does. They can't break a foreign key. They can't put data into a column that shouldn't. As an example, what's the domain of an age? Well, a lot of people would put that in an integer, and that's great, except there's no 2 billion-year-old people. Sorry, there's no negative 1-year-old people. So having an age column that allows from negative 2 billion in something to positive 2 billion in something is not quite right. So you need to say, here's the range we're going to allow, and then put a check constraint on that and make sure it doesn't happen. Make sure our processing values don't get out of sync. If there's a transaction, use transactions. When you save 5 or 6 rows at once, all of them should happen or none of them should happen. You can't prevent users from making all mistakes. If they spell your name IDIOT, can't stop it, right? That's just part of it. Maybe you have a scan that looks for stupid words that they shouldn't be using, misspellings, and you say, are you sure his name's Idiot? I mean, that may be right, but you're probably going to lose your job if you save it like this. So think about that sort of thing. Not all constraints, not all data conditions can be put into check constraints and such, but try to capture as many as you can. These 100% rules, it can never be negative. Make sure it's not negative. So typical systems, I see this a lot. You've got your data warehouse, and it does some cleaning. That's okay, because there's some things maybe you got to integrate multiple systems. But every user process that uses a row has to see if it's right. Is this right? 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 And so you end up wasting a lot of processing time and a lot of brain power every time you build something, cleaning it. Every time you write a report, you have to check to see if it's still correct. The goal, of course, is not to do that. You may still have a bit of cleaning in the data warehouse, but every user process just knows the data is right. The data that was put in is as correct as we could possibly make it. Okay. How do you do this? Well, it doesn't really matter. I did a session at DevLink the other week on data integrity, how to implement data integrity. And the only thing that mattered was that this was true. It doesn't matter if you use check constraints. It doesn't matter if you put anything on there. If you find a way to do multi-user, high concurrency, data integrity, and not use any of SQL Server's fundamental basics, go for it. Impress me. Write a presentation. I'll come to it. I'll buy the book. Okay? But it's not really that easy, because concurrency means people can be doing things all at once. And if two users have access to the data at once, somebody's going to lose, and you're going to lose data, and they're going to be angry at you. So don't just have a bunch of relationships on your data model, because when you put it out there and you don't put constraints, you end up with a bunch of tables that have nothing. So if it looks like this on your model, it looks like this, and you have constraints, you're going to end up with a situation that's a lot better. Because not only is this going to help users to understand what's going on, the engine knows. If the engine says the age, if you put a constraint that says an age value can be between 0 and 140, just being generous, and someone searches for the 2,000-year-old man in your database. If you haven't heard of the 2,000-year-old man, it's an excellent comedy routine. I'll move along now. But if you're looking for the 2,000-year-old man, it'll go, we don't, that value wasn't even allowed 2,000. Toss it out. Don't look for it. So it does that sort of thing. If you try to look for, there's no row in table 1 and you look for a row in table 2 and it has to be not null, doesn't have to do that. He goes, okay, there's no rows in that table. I'm done. So it's good. It's not like magical. It's not always perfect. It's not always helpful, but it's information that's there to help the optimizer out. And if you've ever done a query from the invoice table and joining into the invoice line item, and then just looked at invoice line item, and those numbers don't match, that's where you know you just can't trust anything that's going on. And I've done that so many times with people's systems, and I'm like, wow, this is really bad. How do I trust anything I see? Constraints can be disabled. If you re-enable them, they're not trusted anymore. I'm not going to talk too much about this now, but a trusted constraint means that SQL Server's tested all the values and they meet the requirements. And I've got a procedure at my website, and these slides will be on my website. Today's, and there's previous versions of it anyways. You can go through and it re-enables trusted constraints, non-trusted constraints. Now the question, we tried using constraints and we keep getting errors. So they started using UI code instead. This is a very common argument, and it's a really terrible argument because of two things. One, you can't stop errors. You're going to get a deadlock here and there. You're going to get a little system error, maybe a login failure because the server's bad or server's too busy or something. The transaction log's full. So you need to capture every error and deal with it like it's a problem and do what it needs to be done. But the second thing is, if you get an error, that means something's wrong. That means your code didn't capture it. And like take a foreign key. You grab all the values, you cache them, and you use them for a pick list, and you save the values. Then another user comes back, deletes one of the pick list values because you're supposed to, or they accidentally did it. You save the value, it goes failure. You validated it on the front end, you validated in the middle tier where you have it cached. You didn't validate it at the database, and you get the failure. It's okay to do that. Starting in development, you could start out with no data checking and get errors from the UI, from the database, and then move up to where you're not getting errors at the data level. The goal is to not get errors at the data level. You should never see a check constraint or a unique constraint, if at all possible, violated. But if they do, getting rid of them is not the right answer. Okay, I'm glad I can't hear any questions because people are like, hey, we can't do that in my system. Yeah, and I know, again, sometimes as a speaker, I'm talking from a practical level, perhaps, but not necessarily something that is attainable to everybody. It happens in our systems. I have systems that don't have foreign keys because they've been around for 15, 20 years. So the next part is, if your users are lost, give them a map. Tell them where they're at. So make sure you're documenting things. If you've got a device that looks like this, it's a coffee cup. We know that's, in the real world, that's a coffee cup. But what is it used for? Is it a coffee cup? Is it a pencil holder? A change jar? A sample transporting vessel? Whatever that means. So if anybody can question the purpose of what this thing is, you need to document it really deeply. I mean, your documentation at this level is possibly coffee cup shelf, and you put them on the shelf, right? But as you get more problematic, write it on there. Make sure you document right at the point of use. These are for pencils. This is for coffee. This is not potable liquid in here, okay? And what does potable mean? I'm hoping, most everybody who's here knows potable means it means drinkable. Like you see the truck going by, says non-potable water, it means you can't drink it. But will all your users know what that big word means, or that little word that has meaning that's not common usage? So make sure your documentation is written to your lowest common denominator. You may have stupid people working with you, and not because it's their fault or because that's horrible. It's just they don't know. Stupid doesn't mean, unintelligent, unknowing. They don't know what's going on. And they've got to be told at a certain level, and that's okay. There's nothing wrong with that. There are certain things, if I was working in other industries, I was watching somebody doing with a forklift outside of my house today. I was like, I'd really like to drive that, but if I was to drive that, those people would call me stupid because I would run into things. So you make sure you have documentation so that everybody who needs to understand the situation can understand the situation. Extended properties are great. You can document the structures at a level that people can get to right in the database. Select star from sys.extended properties as a DBA. You can see all the properties. You can get to that information. And don't bury them in documentation that you get from some tool that generates documentation from structures. It's not that that stuff is bad, but that's not kind of what people need. People can gather that information just by looking at, there's a foreign key, so that's related to this table. Great. If I had that in a document that's generated from a tool, that's also great, but for a different purpose, not for the people who are just actively doing work. I hit the B button. And the keyword here is succinct. Make sure, unlike some of my descriptions of what unintelligent people are, your documentation is succinct. I'm trying to be politically correct. I love everybody. It's not a problem. Security. Keep out, right? We put up these signs. Does that really keep people out? Is that the only security we need? Probably not, right? And Joey Bishop was a member of the Rat Pack. Today you can go to a gas station and find the cash register open and the toilet's locked. They must think toilet paper is worth more than money. Well, this seems really stupid, and maybe they don't do that anymore, but I guarantee you that most of the people on this call have access to more data worth way more money than the pencils that it takes them 2 hours to get a requisition for, right? Security is very important. You get this, you don't want to be a headline. You don't want to be the guy, the woman, the person who gets, this GBA from that company was fired. On your LinkedIn page, you've got, I used to work there and got fired about that exact same time. You don't want that to be the case. Because most of us are like Dorothy in the red shoes, or if you're a purist, the silver shoes. She didn't know she had on magic shoes, right? So if your users were poking around the database and just had some time to dig around, they might find a lot of information that they need. If they happen to find your boss's, secret files or something that they need to keep, you could be in a little trouble. So start at the server. Make sure that hackers can't get into the server. That's number one. They can't get into the shell of the server. They can't do any harm. Then don't start granting rights to users if you can avoid it. You end up with people with elevated security forever. So I suggest create a role for every kind of thing in the database and grant access to that role rather than each individual user having their own profile. Even if the role is only used by one user, it's certainly not easier, but it's going to be a lot better in the long run that they go to that area. I definitely suggest not using DB Reader, DB Writer, because that you're just saying, okay, any data that's in that database they can read. Now, what if you want to add some data that they can't read? Now you've got to go back, and if you grant it at the schema level, you say grant select to schema user data to public. Then you can add a secure data schema that no one can read, but you can have it there and do work with it. The goal is to keep databases kind of compact where you can move them around and not have a bunch of dependencies. If you had used DB Writer Reader and you didn't know you could do anything deeper, you'd end up making another database and have two databases that were really more hard to keep in sync. Execute as is a great feature for stored procedures, triggers, but it opens up a lot of dangerous security issues. You know, if you say execute as DBO, I think it's user DBO, that gives them the right to do any DBO work. And if you do dynamic SQL and you don't think about injection sort of problems, you've given the user access to do anything. That user turns out to be some hacker from another system, well, you've pretty much are going to be that headline guy. Encrypt sensitive data. Just like indexes, encrypt everything you need to. Don't encrypt anything less. But it's too slow. Yeah, it's too slow, yes. You can't do a search in an encrypted column, right, until you decrypt it. So you're going to scan the table and incur the cost of decryption. But it's going to be a lot faster than, you know, a lot better than getting in trouble for losing your data. And I'm not suggesting you can't do security in the client code. Just make sure it makes sense. Make sure that people can't get access to the data that they don't need to. Make sure that that security system that gets set up in code actually works and doesn't give them access to too much information. So what are we looking at here? If I asked anybody here, unless you maybe live in a country where they don't have cars yet, which I'm pretty sure is nowhere in the world now, versus anybody on the internet for sure, you're going to say this is a car. And how do you drive it? It's very obvious, right? There's a wheel, and it's got a gear shift here or here. Gears all pretty much work the same. There's a couple of ways to change gears, admittedly, but they've encapsulated things from this futuristic car to this electric car to my Ford Fiesta here to a couple of really old cars. It's encapsulated such a way that nobody has to think, you know, how do I do this? When you go to the rental car company, they don't make you take a class. Have you learned how to drive the new Ford cars? Well, no, I haven't. Well, okay, then you can't rent our cars. No, they say, oh, here's a car. It works the same way, gear shift car. Figure it out. So that's kind of the goal here behind encapsulation. We want to make things just work. Eliminate hints. You know, take out that kind of deep down touching the physical, touching the core engine stuff. So you can let the SQL Server do their work. Select star from table, you've encapsulated yourself from the storage. Select star from table using this index, you've now fastened your wagon to that bit of physical storage. Don't make the UI and the table structure the same thing. That's a really horrible problem because then you either have 50,000 screens or you have one table. UIs change all the time. We built databases 20 years ago that we use, well, 18 years ago, they use SQL Server 1.0 and almost all that code would work. The UI is probably not the same UI, however. It is in some cases, but it doesn't have to be. And then a layered approach. Stored procedures are a great candidate to replace queries, not necessarily big processes and complete, but just the more kind of succinct your stored procedures, the better. And that will help you parameterize your queries and optimize them as needed. Data drive your design. Don't make a bunch of lists that people have to like go and say, you know, row 1, 2, 3, 4, 5, and 6, and then tomorrow it's 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, that sort of stuff. So get away from getting to those physical structures. Another one is Surrogate keys. You have surrogate keys. Let's say you have a table called company, and you've got company ID, which is a surrogate random value that you've assigned to them, and you've got company name. Well, the company ID is for programs. So when programmers access the data, you translate that, they take the code, they use that ID, and they do all their queries that way. We don't make users use that. When a user wants to get to a company, they take the company name or the company code or whatever you'd set up, and they go in with this human-readable value. It gets immediately translated to the surrogate key, and then the surrogate key does all the work. So we encapsulate those details of how things are implemented away from the user and give them things that look and feel like they're real world. So with 4 minutes to spare, the things that have to be done: make sure it works. Okay, make sure it works fast. Make sure it's normalized so it works well with the engine. Make sure that everybody can understand what's going on without any kind of documentation if possible. Make sure it's fundamentally sound. All the data is right, is as right as it possibly can be. Everything that's not understandable by normal, the normal users is documented to a level that everybody in the company can understand who's going to need that access. Make sure it's secure. Only the users who can get to that data can get to that data, and not everybody else. And it's encapsulated. So if you change the structures, it still works. The reality is this isn't about job security. Okay, don't make things complicated for yourself for job security. They get rid of bad people more than they get rid of good people. It does happen. I know there's those examples, but so as long as if we find a tool that'll do this without our help, I'm good. I'm glad. I hope I was part of the team building it, or I'm gonna be looking for another job. But I don't want to do something that can be done manually. That bulldozer does a much better job than me with a shovel. All right. So if you have any questions, I'm fully willing to answer them for the next 35 seconds.
All right, Lewis, I'd like to thank you for your presentation. A gentleman has one question left. He says, were there any situations where you could pass on the processing load to the ETL servers like SSIS instead of letting the database engine, I guess, do the work? I'm not sure what he's asking there.
For data warehousing, yes, but not for normally OLTP systems.
So mainly what you're talking about is the transactional systems where you're trying to put the constraints in the database, not necessarily processing.
Yeah, because I mean, when you do ETL, you have one user interface, one tool that does it. I mean, I know we put constraints on our data warehouse because it keeps us from making mistakes. But you have one tool. If we only had one user, one tool, it's okay. I mean, if I build a database for myself to capture my Disney pin collection, I don't put constraints on there that check everything down to the independent level. But if I made a database that the whole entire, everybody on the call here could use to do that, I would, because I know what I need to do, and when I do my scan, I go, oh, that's wrong. I fix that. But not everybody knows the rules, and if the rules are done by the database, at the very least, it's stopping you from making mistakes.
All right, we have one more question. Actually, there's two. One says, great job. The other one says, thanks. There's also a gentleman that...
I like those kind of questions.
There's also a gentleman that referenced a RETTEG, R-E-T-T-E-G normalization poster. It's on informationqualitysolutions.com. So there's a free poster of normalization out there. And it looks like the last question is, I saw that you mostly split a denormalized database or table into two tables. How about three tables with a hamburger table in the middle? Would you advise this in terms of vehicle and person as two separate tables and then a linking table between the two? I think he's talking about like a many-to-many relationship.
I want to know more about this
hamburger table.
That sounds
yeah,
really good.
Yeah. I think he's talking. So he references an example of a vehicle and a person. So more than one person might be in more than the same vehicle.
Right, and that's a different design altogether.
Okay.
If you're implementing a many-to-many and you have one person, if we were representing an actual car and an actual person, right, that one car is probably used by more than one person. So you would definitely have a many-to-many relationship there and have person, vehicle, and vehicle. I mean, if this is what the requirements state, because it's all about what the requirements come up with. Hamburger table is an excellent name.
Well, now someone else is calling it a joint table.
You say joint because
Yeah, joint table. I think I mean joint table.
It's not funny. Typos are not funny. I feel bad about talking about less intelligent already today. So
All right,